what is Kubernetes kOps? What is Kubernetes kOps? Well, if you have heard about Kubernetes, and if you have also heard about setting up a Kubernetes cluster on any of the cloud accounts, either AWS, Google Cloud, doesn't matter which one, then I am pretty much sure you might have heard about kOps or come across this word kOps. They might ask you this question in the interview. But again, if you have not worked with kOps, this is your chance to understand it and prepare for the interview. You can pause the video here to see how you would answer it. Now let me go ahead and give you a bit more detail about kOps and how to answer this question in the interview. kOps basically is a way in which you can set up a Kubernetes cluster instead of using kubeadm or kubeadmin. It is an automation tool that you can use to set up a Kubernetes cluster on any cloud service. kOps is not something that will help you to set up a managed Kubernetes cluster like EKS. What is a managed Kubernetes cluster? It means that everything regarding the cluster is taken care by the cloud, but kOps is not that. It is used to set up a cluster quickly. And one of the use cases for that is you can spin up a test cluster or a small dev cluster using kOps very quickly in the cloud and test your application, deploy your service, or do any kind of load balancing. kOps will not help you to only create the cluster. It will also help you to destroy it, upgrade it, and maintain it in production grade if required. But I wouldn't suggest it so unless and until you can't use any managed Kubernetes service. So what is kOps really doing? You might be wondering, can't I just use kubeadm to do it? You can. But remember, when you set up a Kubernetes cluster in cloud, you would need integrations with EBS, right, for volumes. You need integrations with EC2 for spinning up machines, ASG for spinning up the auto-scaling group, and then Route 53, whatnot. So the issue that you will face if you just use kubeadm is integrating with all of these external services. And that is where our kOps comes into picture. And it will help you to make all of these integrations happen if you use kOps to set up the Kubernetes cluster in AWS. As of today, it supports AWS, DigitalOcean, GCE, OpenStack, etc., etc. Okay, how do I answer this question in the interview? kOps is an automation tool using which I can set up Kubernetes cluster in a cloud account. It helps me to automate the whole setup process, destroy the cluster or upgrade the cluster or maintain the cluster in production in cloud service if I cannot use any of the managed Kubernetes service for whatever reason it is. If I were given a chance to use kOps, then I would use this to set up a quick development or testing cluster in my company so that if we want to do certain kind of testing, load testing, application testing, we can quickly spin up a cluster, test it, and then destroy it using kOps. This is how you can answer this question in the interview. That's it for this particular video. Let's meet in the next video and continue our journey preparing for DevOps interview. Thank you. Explain a replication controller in Kubernetes. Replication controller in Kubernetes. If you have taken any Kubernetes training as a part of being a DevOps engineer, I am pretty much sure you would have learned replication controller. And that is exactly what the interviewer wants to know from you. It is a fundamental question with respect to understanding the architecture of Kubernetes? Okay, you can pause the video here to think about the answer and see how you would have answered in the interview. But let me go ahead now and first explain what is replication controller, and then how it is handled, how you can handle this question in the interview. So what is replication controller? Replication controller is nothing but it is responsible for maintaining the number of pods in our cluster, across the cluster, basically in our cluster or across the cluster. So usually we represent replication controller in rc.yaml. And in this rc.yaml, if we mention that we need 3 replicas, then there will be 3 pods running, maybe on the same node or different node. Maybe pod 1 and pod 2 can be on node 1, for example, and pod 3 can be node 2. So that is not a problem for us. That is why we are mentioning across the cluster. So when do we use replication controller? When we want to do certain kind of scaling. Just now we understood what is horizontal scaling, and here comes the best example for it. Replication controller can be mentioned in the YAML file, and I have given an example on the right side. And you can see I'm calling the kind. I'm calling the kind replication controller here to use replication controller. Okay. And here I'm giving a name, and here is where I'm mentioning the replica information, how many replicas I need. And the replication controller will handle and make sure at any given point of time, we have 3 replicas, that is 3 pods are running in the Kubernetes cluster. Replication controller is very important when you have an application that is handling traffic, and you can make sure that the replicas are present to handle this traffic. There are other informations in the YAML here. I'm not going to go and explain that because that is not required as part of this question. But I believe you understood what replication controller is and what it does as a part of its use case in Kubernetes. So how do we answer this question in the interview? We can say that replication controller in Kubernetes is one of the controllers that is responsible for making sure that X number of replicas are present at any given point of time in our cluster. This X number can be 3, 2, 1, doesn't matter. It is very important for us to have replication controller if we want to have a kind of horizontal scalability present, meaning we have 3 and 6 in future, or we have to have high availability present. This is how you can answer this in the interview. I would like to mention one important point here, my friends, that is replication controller is not auto scaling. It is not horizontally scaling, meaning it will not automatically scale this number of replicas from 3 to 10 just because there is some traffic. No, it will not do that. For that, there are other features in Kubernetes. I am pretty much sure you're aware of it. If not, such kind of questions will appear in the other video sections when you continue watching these videos. Well, that is it for this video. I hope you understood how to handle this set of questions in the interview if it is appearing. Also, congratulations that you finished the first whole part of this. We are going to the next leg of our training, the second leg, where we are going to understand more interview questions across different domains. Thank you for watching this video. Speak to you in the next video. What is PV and PVC in Kubernetes? What role do they play? When you have taken the Kubernetes training or when you have learned Kubernetes in your organization, I am pretty much sure you have come across these questions. And as we are learning more and more interview questions, we will be going in depth on such concepts. So yes, you can expect these questions in the interview, and these are also fundamental topics in Kubernetes. Well, you can pause the video here to see how you would answer this question in the interview. And let me go ahead now and first explain a bit about PV and PVC, and then let you know how to answer this question in the interview. So what is PV and PVC? The full form of PV is persistent volume, and the full form of PVC is persistent volume claim. So we will take an example to begin with. Let us say we have a pod, and inside this pod, we have a small container running. And this container is in need of a volume. Well, why would a container be in need of a volume? For anything, to write some logs, to dump some information, etc. So the question is, from where will it get the volume? Many people say that, oh, it is going to get directly from EBC, or it can use the node volume. No, it cannot, because remember, this is a pod. And inside this pod, we have a container. Well, it's not that easy that it would just go and grab any EBS volume or any volume storage layer for that purpose to run. So what happens is the pod will have something called as PVC, that is persistent volume claim, which will actually get hold of PV, that is the persistent volume generator, which will then share the volume. Okay, it might be becoming a bit of confusion. So let me explain this in an easier way. So let us say you want to take a flight and you want to fly somewhere. So what do? You visit a website, right? And on this website, you're going to search for the required flights, and you're going to find a flight that is suitable for your journey, and you're going to book it. And you're going to get a ticket for it, right? So you have a ticket. Well, this is an actual document that is required for your journey. Is it true? Not really. An actual document that is required for your journey is the boarding pass, BP, right? And the boarding pass is something that you get when you actually visit the airport. Am I right? So when you visit the airport, you are going to show your ticket, right? You're going to say, hey, look, I have a ticket. I have booked a flight to place A to place B. I want to fly. And then the airport staff are going to give you a boarding pass, which will allow you to go and take your seat in the flight. So what's really happening here? There is a process that has been established, and this is the same example we can use to understand PV and PVC. Let us try to implement the same example in PV and PVC. So we have a volume, okay, and we have a pod. And this pod wants to use this volume. Can it just go and get this volume? No. It is first going to create a PVC saying that, hey, I need a 1 GB volume, and the volume has to be SSD or NFS. So that is the claim. Now, what would the PVC do? It would go and search for PVs in your Kubernetes cluster, which are basically the ones that have provisioned this volume, and find a volume that suits the requirement, and then it will allot this volume to the pod. I hope it makes sense. So this is what PV and PVC is. So here you can relate the boarding pass, which is an actual boarding pass, as what you can think as your PV, and your ticket as PVC, right? So your PVC will lead you, that is your ticket will lead you to get your boarding pass. So the PVC will lead you to get your PV, that is a persistent volume. Well, I hope I have explained this in as concisely as possible, but I'm pretty much sure you have learned this concept in the Kubernetes training. So you should be able to relate to it much faster. So how do we answer this question in the interview? PV stands for persistent volume and PVC stands for persistent volume claim. To get a PV, that is to get a persistent volume, we need to use the persistent volume claim in our deployment section or in our whole YAML. And we should request the PVC to find a volume that is required for us. And the PVC will take the responsibility of finding the PV for us. And if it is provisioned, will allot to this pod. Just having PV or just having PVC will not help us to get the pod, because that is not the way it works in Kubernetes. So PVC and PV both work hand in hand if it needs to be attached to the pod. Well, I would like to mention one point here, that PV can exist independently of your pod. It doesn't mean that if you have a PV, that is, if you have a persistent volume, it doesn't mean it has to be attached to a pod. No, there can be a persistent volume that is not attached to the pod and it is totally fine. It is just there on the node or attached, and later a PVC will come and it will claim this particular volume and give it to the pod. This is how you can answer this particular question in the interview. A pod is trying to access a volume, but it gives access error. We would like this pod to have access to this volume. What can we do to achieve the same? And this is a very, very practical question. And they are trying to ask and see if you have really worked on Kubernetes and you have hands-on experience on Kubernetes and have seen different issues with respect to volumes. Also, this question can be answered if you have understood Kubernetes volumes properly. You can pause this video here to see how you would answer this question in the interview. Let me go ahead now and explain a bit about volumes in Kubernetes, and later I will explain how to tackle this question in the interview. We have to understand a bit about how this is done, how this is accessed in the how volumes are built in Kubernetes. To begin with, volumes are basically handled, or volumes are basically provisioned in Kubernetes as a part of our PVs. And we have seen the previous questions around PVs already. So I'm pretty much sure you guys are aware of this. The issue could be coming, or the issue could be appearing because of our access mode to the volumes, On the right side, I have given one example. We have pod number 1 and we have pod number 2. And pod number 1 has 2 volumes attached, that is PVs. And how does it get attached? It gets attached via PVC. The volumes are actually getting attached because of the PVC. And this particular volume has a read-write once, and the second volume here has a read-write many. And if you observe carefully, this green line, that is the PVC around this one, are successful because the volume here has a read-write many as its default permission. And the volume also supports read-write many. Speaking of the first volume, it is of a type read-write once, meaning it can only support one pod at a time if it is attached. So if pod number 2 tries to get attached to this particular PV, it is going to fail because the volume supports only read-write once. I hope the logic around this is now clear. When you are provisioning any kind of volume for that matter in the Kubernetes, it is very important for you to be aware that what will happen is each of these volumes will have either of these parameters, that is read-write once, read-write many, read-only many, read-write many, and read-write once pod. Okay. Some of the examples I would like to give is the NFS volume, that is network volume, allows and handles read write many, wherein the EBS volume that we have will handle always read write once. Okay, so what could be the issue here? The issue here would be that the pod is trying to access a volume that is having read write once, and hence it is giving access denied error or access denied issue. Okay, then. So how do we handle this question if it is asked in the interview? The error could be appearing because we might be trying to attach a particular volume which only allows read write once. Because of this, the pod is having some issues. The solution for this also is we make the changes in our PVC and PV to make sure that a separate volume either is created for this, or we make sure that the volume that we are trying to attach supports read, write, many permission. This is how you can tackle this question in the interview. On a side note, you can also add that the example of read write many is NFS, and an example of read write once is EBS. Well, that is it for this particular video. Speak to you in the next video. Thank you. Now let us go to the next question and understand what the question is. What is a sidecar container? What is a sidecar container? Many of you would have heard about a sidecar container. When you were learning about Kubernetes, they would have taught you about sidecar containers. The question is, what is a sidecar container? Just a minute ago, I explained the concept of logging. Logging is a part of application. So we will take a small example now. Let us assume we have a pod. We have a pod. This pod can have containers. So let us zoom in. So the pod, I have just zoomed in this approach, okay? And we will have container. Container 1, container 2, container 3. We can have multiple containers here. Let us see these containers. They can be built and they can be destroyed, right? This container can be destroyed after some time. What will happen to the log here? It will also be lost. Point number 1. Also, what is common in all of them? All of them have to do logging. Can I extract this feature and run it separately as a part of this application? Yes. So I can have one more container here. Let me use a different color maybe. I can have one more container here, which is the sole purpose of this container is logging for these applications. And this sole purpose of this container will be to collect all the logs from this different containers in this pod and then send it across to centralized logging. This makes more sense for us and gives us more flexibility in terms of deployment, scalability, etc. This particular container is called a sidecar container. So sidecar containers, in other words, is a container that helps you take away a common functionality of your application, and then they run along your application in the same pod. This gives you more flexibility. So how do you formulate this answer in the interview then? This is how you can explain this answer. Sidecar containers are containers that help the application running in the pod to perform some common task. The most common example would be logging, and we can have a sidecar container which has a purpose to send the logs from the application container to our centralized logging system. This mechanism will help us to make sure that a common use cases across our application can be separated, and sidecar containers will help us to make sure that our deployment is smooth, and it will also remove certain complexities when we build application and make the application much smoother to deploy, scale, and manage in production. This is how we can answer this particular question in the interview. Well, that's it for this video, my friends. Speak to you in the next video. Till then, take care. Bye-bye. We want to launch certain pods only on specific nodes. These nodes should explicitly used only for these pods. Is it possible to control the deployment of pods in such a given scenario? Observe the question very carefully and try to see what could be the solution for such a use case in Kubernetes. This is a scenario that probably will be used in real time in many projects. Hence, it can be expected that they feel you will be aware of such a scenario. Very well, you can pause this video here to see how you would answer it, but let me go ahead and try to explain this concept for you. The whole idea around the explanation is coming from the Kubernetes concept called as taint and tolerance. So what is a taint? A taint is something that when it is attached to a pod, it is going to repel the pods from getting provisioned or getting accepted. I will give you one example to make sure you can relate to my explanation. Let us say you want to go and watch a movie. When you want to go and watch a movie, you can buy certain kinds of tickets. The first kind of ticket is a normal one, right? And the next one is deluxe, let's say. Now, what's a deluxe ticket? Maybe you get a free popcorn and the leg space is different, right? And the chair in which you're going to sit is more comfortable, etc. Normal ticket, maybe you have to buy your own popcorn and you have a normal chair and that's pretty much it. But how do you know when you look into a particular chair, how do you know that this is a deluxe chair or this is a normal chair? There will be some labels here, right? They would have put some labels on this. Similar way, like I just explained you this concept of the film theater or the movie theater, in Kubernetes, let us say that we have a Kubernetes cluster, and this cluster has machines or nodes. We have 3 nodes here, node 1, node 2, and node 3. In this particular given scenario, let us assume that in node 3, we want to run only defense applications, okay? Now, when we launch this application, the pods should get provision only on node 3. This is our use case. Only on node 3, all these defense application pods should be provisioned. How can we do that? What we can do is we can add a taint, like you see above, on node 3. And what happens is we can give this taint information in our deployment. And because of this, when this pod gets into the provision state, the scheduler, which is responsible for deploying it, is going to check the taint criteria, and it is going to make sure it gets provisioned in node 3. What about other kinds of application? Let us say we have another application, application X, let's say, application X. If it wants to deploy this application in pod 3, because of the taint that is attached to this pod, it will repel this pod off, saying that this particular pod from application X cannot be deployed on pod number 3. Also, not just this is an example. If you want to do some maintenance on this particular pod, you can also attach maintenance taint so that no new pods will be provisioned on node number 3. I hope this explanation was enough to explain you what is taint. There is also a concept of tolerance, which will be used in hand with taint. And if you have taken any kind of Kubernetes training, you will be aware of this concept. So you can go back and read about it. and try to also experiment this practically if required. So how do you answer this particular question in the interview then? To achieve this kind of result, we can use the taint and tolerance methodology in Kubernetes. Especially, taint is a methodology in which we can label our nodes according to our use case, because of which it will repel all different kinds of part which doesn't match the label. For the application that we want, we can make sure that it has a proper label that matches the taint label, and hence it can get provisioned on that particular node. I hope you are able to see how you can answer this particular question in the interview. Hope you have understood how to tackle these questions if they appear in the interview. See you in the next video, and thank you.
Hello and welcome back. It is time for us to review one more interview question regarding Kubernetes. And the question is, how does the K8 scheduler quickly assign worker nodes for the pods? Explain the internal working of K8 schedule. So what is the interviewer trying to ask you here? They are trying to understand if you are aware of the internal working of Kubernetes schedule. We all know that Kubernetes scheduler is responsible for scheduling the pods on different worker nodes. But that is not the answer they are looking for in the interview. What they are looking for is to understand how does Kubernetes scheduler really provision these pods so quickly on the worker nodes? How does it have this information beforehand so that it can provision these pods on the respective worker nodes? Then let us try to understand this now. Every worker node keeps on sending their information to scheduler. We are aware of this. And this particular information, or we can call it as metadata, that has been sent to the Kubernetes control plane, few set of informations are always stored, like the health of the overall instance, the load it is currently on, etc. These metadata determines how healthy this particular worker node is. With this information, what scheduler does is prepares a list. First, it filters and then it scores. And based on these two steps, it has a list of worker nodes that are healthy worker nodes. So one part is it has all the information that it requires to know where to provision the pods. That is, where do I put the pod, which worker node is already healthy. And this information is already kept handy for the scheduler by performing two steps, that is filtering and scoring. Now what happens is every pod then goes through what we call as pod scheduling cycle. There is a service that is responsible for taking a pod through this life cycle, where a pod information is passed on, that is, how much resources this particular pod requires. And once this information is determined, it is cross-checked with the information that the scheduler has, that is, which worker can handle this pod, and they are matched accordingly. This is the internal working of the scheduler, and that is why pods are provisioned very quickly on the respective worker nodes in Kubernetes. We can stop here to see if they're going to continue to answer the questions related to this particular topic and dive deep here. Okay, so how do you present this particular answer in the interview? This is how you can present this answer in the interview. We are aware that scheduler is responsible for provisioning the pods on different worker nodes. What scheduler already has is the information, or what we call as metadata, of each worker node. That is, how healthy this particular worker node is. Then this information is filtered and scored. There is a particular rank that is available for each worker node. When a pod comes for scheduling, through its pod scheduling lifecycle, the information is then correlated to the data that the scheduler already has. What is the requirement of the pod and which worker node is present, that will give us enough resources for this particular requirement, and they are matched. and the pod is provisioned on this particular worker node. Because of this metadata that we are getting from the worker and also a proper filtering and scoring methodology inside the Kubernetes, it is very easy and faster to provision pods in Kubernetes. This is how you can answer this particular question in the interview. From here, the interviewer might choose to go in two different directions. One, they might want to understand a bit more related to pod scheduling cycle, or they might be interested to know more related to the worker setups that you are currently having in your organization, etc. Well, I hope you have understood the question and the answer. Most importantly, how to present this if this question appears in the interview.